solving multi-step equations. So we're going to look at how to solve equations that have more than one step to them. This is the first of two videos, so make sure you watch this one and then the one on consecutive integers. So solving multi-step equations. We know how to solve one-step equations by doing the opposite of adding, subtracting, multiplying, and dividing. Now we're just putting that all together. So let's take a look at a few examples. So 2a plus 11 equals 3. I want you to think about that equal sign as the middle of your equation. Doesn't matter how long one side is compared to the other, that's always the middle, and whatever's on the left is equal to whatever on the right. We show our work going down the page, so we're going to show our steps as we go along working down the page. So I'm going to start kind of do backwards order of operations to solve equations to get the variable by itself. That's how we know when we're done. The variable is alone. So let's get this a by itself. We're going to start to do that by getting rid of this 11 first. It's adding 11, so we're going to subtract 11 from both sides. That's how we keep the two sides equal to each other. When I subtract 11, I have 2a equals negative 8. These two sides, this is an equivalent equation. It represents the same amount as what's up above it, and a is representing the same value for a. We want to get the a by itself still. That's always our goal. We need to divide by 2. We're showing 2 with that fraction bar, please. Please don't use the line with 2 dots over it anymore. That can get confusing as to working with larger expressions. If we use our fraction bar, it reminds us that we need to divide the whole left side and the whole right side by our value. So divide by 2 on both sides, we end up with a equals negative 4. Pretty straightforward. How do we check that? Most of the checks for what we're doing will probably be mental math, but if I were to write it out, this is what I'm doing in my head. Taking the original equation, I'm taking out the variable and I'm substituting in, there's my substitution property, substituting in the value that I just came up with as a solution. I put a negative 4 in here. I have 2 times negative 4 plus 11 equals negative 3. Negative 8 plus 11 equals negative 3, so both sides equals negative 3. My answer is correct. Let's try another one that has some different operations in it. B minus 19 over 12 equals negative 2. So I want to get rid of this 12, this dividing by 12 first. We can think about fractions here as if both parts, the numerator and denominator, are in parentheses. So I really have to kind of get things out of the parentheses before I can really work with what's inside the parentheses. So I need to kind of split those up. I want to get rid of the dividing by 12. I'm going to multiply by 12. How I want you to show multiplication on both sides. I want you to put the entire left side in parentheses with whatever your factor is on the outside, and the entire right side in parentheses with your factor on the outside. This will help us remember our distributive property, that we're not just looking at the 12 here, we're really thinking about the whole piece of that. Now when we go to multiply this, what we're really doing here, this is a fraction, and I can only multiply fractions by fractions. So what really happens here is this is really 12 over 1. The 12s simplify out. That b minus 19 remains by it all alone. It's just b minus 19. The 12s have canceled themselves out. There is no 12 times the b and 12 times the 19 because the 12 in the numerator and the 12 in the denominator just were common factors, so they're gone. So my left side remains b minus 19. My right side is a negative 24. I still need to get rid of this subtracting 19. I'm going to add 19 to the left and the right. I end up with b equals negative 5. Let's look at a word problem. All right, Susan's shopping. So here's our word problem. Susan had a $10 coupon for the purchase of any item. She bought a coat that was half its original price. After using the coupon, Susan paid $125 for the coat before taxes. What was the original price of the coat? I'm going to say this now, and I'm probably going to say this again and multiple times. We are working in an algebra classroom. So we are using all of the situations that are thrown in front of us to practice our algebra skills. So I want you to dig into your bag of algebra tricks to solve these problems. Could you solve this in your head? You probably could. I'm not questioning that, and there's nothing wrong with doing mental math. Absolutely nothing. However, we're practicing our algebra skills. So anytime you see any kind of a word problem, I want you to write an equation. And you need to start writing an equation by identifying your variable. So you need to tell me what you're going to use for your variable. Now what you see here over on the left, you'll see me do every now and then. This is what I call a T-chart for a word problem. Sometimes I get into the middle of a word problem and I'm not really sure how to start. So what I would suggest you do, if you're completely baffled, is start by making a 2-column chart. On the left side, write out any numbers in your word problem. So I see a 10 here, I see a half, and I see a 125. So I wrote those out. Then I went through and on the right side I labeled what each of those numbers mean in the word problem. So 10 is the amount of money she's getting for her coupon. Half is how much off of the original price she is going to get. And 125 is the final cost of the coat. The last thing I want to do in this T-chart is figure out what I need to know, and they want to know the original price, that's what they're asking, and then I'm going to come up with a variable to represent that missing piece that I want to know. So this kind of takes out all the extra words in your problem and boils it down to just the important parts. Then I'm going to start to look for some really key phrases. So for instance, I see in here, final cost. That's a final cost of the coat. That's a total. That's an altogether. It's a final amount. So I'm going to put that on one side of my equation completely by itself, because that should be a total once I do all my math. The other thing I see in here is of. This is half off of the original price. This means I'm multiplying of my times my price. So I'm going to take 1/2 and I'm going to multiply it by my original price. So I'm going to do half times the original price. And I've still got that $10 coupon. I know a $10 coupon means I have to take it away from whatever I'm paying. So I'm going to subtract the 10 from that. All right, so once we've got our equation, you don't have to do a T-chart. Let me just point that out. This is purely, I'm completely, totally stuck with this word problem. I have no idea what to do. That's what you can do. If you can go straight to the equation, fantastic. So let's take our equation, 125 equals 1/2 p minus 10, and let's solve for the original price of this coat. So we're going to add 10 to both sides. I get 135 equals 1/2 p. Now I need to multiply, I need to get rid of this 1/2. We multiply by the reciprocal. We do not divide by fractions. Highly illegal. We multiply by the reciprocal. So I have parentheses on each side because I'm multiplying by 2. I end up with 270 equals p, so the original cost of the coat is $270.